Hello everyone, this is a lecture from the Essential Calculus Problems series on the North Campus Calculus channel. In this series, we focus on solving exactly one calculus problem per video involving limits, derivatives or integrals. And in this lecture, we will solve the integral of cotangent cube x dx. Let's write the integral again. We will solve cotangent cube x dx. In order to solve this integral, you should firstly know the derivative of cotangent x, and also you should know that cotangent square of x is equal to cosecant square of x minus 1. And the derivative of cotangent x is equal to minus cosecant square of x. You may not remember these two equations, but if you do not remember them, you should know that in order to remember this derivative of cotangent x, you should write it as cotangent x as cosine x over sine x and then differentiate it. If you use here the quotient rule while differentiating it, you will get minus cosecant square of x dx. And also, if you do not remember this equation, you should write cotangent x as cosine x over sine x. And these two methods are always used in the integral of trigonometric functions. And the way that we use here in cotangent x can be used also in the integrals of tangent x. And for the cotangent square of x, let's say it here, cotangent square of x is equal to cosine square of x over sine square of x. You may not remember this equation, and you will do what I show you here. Okay. Cosine square of, you know that sine square of x plus cosine square of x equal to 1. Then you can write, instead of cosine square of x, here cosine square of x is equal to 1 minus sine square of x. And here we can write 1 minus sine square of x over sine square of x. And this is equal to 1 over sine square of x minus sine square of x over sine square of x. 1 over sine x is cosecant x. So we have here the square of cosecant x. So we can write cosecant square of x minus, and this is equal to 1. And this means that cotangent square of x is equal to cosecant square of x minus 1. Then let's go to the integral, and I will raise them. Okay. In order to integrate cotangent cube x, we should rewrite it as cotangent x times cotangent square of x dx. And after that, we will use this identity, and we will say that cotangent square of x is equal to cosecant square of x minus 1. We say that reduction. If you have an integral of cotangent x that it has an exponent of 3, 4, 5, 6 or etc., we use reduction because in order to integrate the cotangent x, you should have here just 1 as exponent or 2. Okay, and the integral becomes the integral of cotangent x times cosecant square of x minus 1 dx. Then multiply this by cotangent x. Then the integral becomes cotangent x times cosecant square of x minus cotangent x dx. And we can split this integral into two parts. This will become cotangent x times cosecant square of x dx minus the integral of cotangent x dx. We will solve these two integrals one by one. Firstly, let's solve the integral of cotangent x times cosecant square of x dx. Okay, this is an important integral here. If you have cotangent x and cosecant square of x dx, always you use substitution. Why? Because the derivative of cotangent x is equal to minus cosecant square of x dx. This says that we should use substitution here. You may have, for example, cotangent to the power of 5x times cosecant square of x, or cotangent square root of cotangent x times cosecant square of x, etc. Always you will use substitution. Why? Because the derivative of cotangent x is minus cosecant square of x dx. If you have a function, and its derivative is multiplied by dx, you always use substitution method. So we use here the substitution. And how will we use it? We say that cotangent x is equal to u, and take the derivative of both sides, and minus cosecant square of x dx is equal to du. This means that cosecant square of x dx equals to minus du. Then we say that here this part is minus du, and we said u equal in cotangent x is equal to u. Then the integral becomes integral of minus u du. The integral of minus u is minus, we add 1 to the exponent 1. Here we have exponent 1, and we add 1 to it and divide by the new exponent 2. Then this is equal to 1 over 2 times u to u square. And since we have u as cotangent x, the integral becomes 1 over 2 times cotangent square of x. And this is the first integral. And the second integral was cotangent x dx. Let's integrate cotangent x dx. In order to integrate cotangent x, we should firstly rewrite it as cosine x over sine x dx. And we have here a function sine x and its derivative cosine x multiplied by dx. If you have a function and its derivative multiplied by dx, you should always use substitution method. Here we say that sine x is equal to u, then the derivative of it cosine x times dx is equal to du. Then we say that cosine x dx du and sine x is u. And the integral becomes integral of du over u. And here we have d over u is 1 over u du. And we know that the integral of 1 over x is ln absolute value of x. So the integral of 1 over u will become ln absolute value of u, and u here is sine x. Then the integral becomes ln absolute value of sine x. Now our integral was this. Our integral was this, and this integral was equal to what? 1 over 2, okay. Minus 1 over 2 cotangent square of x and minus this integral was equal to ln absolute value of sine x. And since the integral here was an indefinite integral, we will add the constant c, and the answer is this. In the next video, I will solve the integral of cotangent to the 4th power of x dx. See you in the next video.